Hi, my name is Andrew McLaren, and I'm going to help you with solving for the final temperature when you've got two different substances at different initial temperatures, and you're trying to figure out roughly where that final temperature should be. So my biggest tip to students on this is to not just do the calculation. Sometimes plugging in numbers, your algebra is going to get messed up, like you're going to mess up one of the signs or forget it. It's really, really common. So we're going to focus on estimating the answer as well as plugging it back in before and after doing the calculation to actually see what makes sense. So there'll be a little bit of a concept overview when we're doing like the game plan. So when we're looking at this problem, you know that the final temperature is going to be anywhere between these two different initial temperatures. We've got one temperature there, and we've got a different temperature there. And so our final temperature should be somewhere between there. Now it might be closer to the 25, it might be closer to the 100. It kind of just depends on the amount of mass and the C value of the thing involved. So if we're trying to estimate this, what you want to think about is your Q equals MC change in T formula. And think about how these two things are related. So there's going to be two different formulas that they're very similar, but they're going to have different temperature changes. So they're going to have different Q values. One of these is going to be for the water. So I like to do my subscripts on all the things just to make sure that I'm plugging in the right stuff as I'm doing this. And then we've got gold. So this works out nicely with our subscripts. Now, these two Q's, they're going to be equal and opposite to each other. So QW is equal to QG in terms of their magnitudes, but they're opposite in terms of one thing gaining this much Q and one thing losing this much Q. So it looks to me like the water is going to be going up. So that is going to have a positive value. And whatever this Q of the gold is, that's going to have a negative value. Now these should be equal to each other in terms of their magnitude, but they'll have opposite signs, which should make sense because the water, this temperature change, is going to be positive. C is always a positive value, same with M. So if the change in T is positive, then the Q is also positive here. So you can imagine that this is going to be the opposite case here. If you've got a change in T that's minus, you've got a Q that's minus. So to really set this up correctly, you'll sometimes see people use this formula of Q1 is equal to the negative of Q2. That's just taking account of these signs. So if this number was like a plus 100, this would be a negative 100. So plus 100 is equal to a negative of negative 100. And this is the key, is that recognizing that you're going to set these two things equal to each other, but they're going to have opposite signs. And so these change in T's are going to be opposite in terms of the signs that they have, but the general expression is equal to each other. So these two things are kind of equal to each other, at least in terms of the magnitude. Now, if we want to keep this truly equal to each other, we got to stick a negative out front of that to turn that negative Q into a positive value to make these actually be equal to each other. So there's a lot of work that goes into just like thinking through like what you're gonna have to do with the numbers here. But the big picture here is just look at the magnitudes on these things. And I'm seeing like masses that we can plug in here and some C values that we can plug in here. And I'm just going to get a rough estimate of those numbers multiplied. Just think about which of these temperature changes should be bigger. So if we're looking at water, it looks like we've got 50 grams of water. I'm going to write my substance as well as the units. And then the C value for water, that's something that wasn't given in this problem, but you'll probably have this memorized. And that's going to be 4.184 joules per gram degrees Celsius. And you can kind of see how the grams would cancel out and the Celsius would cancel out to give you joules for the Q. So we've got those two numbers. And then we've got on this side, we've got a, what is that, 200 gram block and 0.129 joules per gram degrees Celsius. Now, if I just multiply these two numbers together and multiply these two numbers together, I'm just seeing that this is about 200-ish. This is about a tenth. It's a little bit more than a tenth. So I'm going to say this is like 20 or 30-ish. So it's somewhere in that range. So we can see that one of these should have a bigger temperature change than the other. So this has a big number next to it, so it gets a small number next to it to make it equivalent. So this is kind of small, the water change, and this is kind of big. So if you want to use this as like a ratio, you've got 20 to 200. So this looks like it's about 10 times bigger temperature change. If you were to compare to that. So essentially, if you're thinking about this in terms of rough numbers, I think I've worked through this problem and it ends up being of a difference of this is like 10 times bigger drop than this is a increase. So this goes up by like, I think it was like 7 degrees and this goes down by about 70. So you can get a rough idea if your answer is reasonable without doing any of the actual number calculations here. But we'll actually go through the calculations and help you keep track of those signs in the next section. So I've already talked through like the overview and thinking through the math in the estimation piece. The main thing being is that these Q's are opposite in terms of their charge, and so you're going to have a negative in front of one of them to make the two actually be equal to each other. If one is going up, then the other one has to go down in terms of its temperature change until they get to the same T final. So if we want to write this out, we've got essentially the numbers here. So I'm just going to copy paste them into the formula and actually calculate these values. So we've got this for our mass of the water. We've got this for our C value of the water. Those should be multiplied by each other. And then that's going to be multiplied by this change in T, which is going to be the T final minus the T initial. But I believe we have T initial. So let's go ahead and plug that in. So for water, this was an initial temperature, yeah, of 25 degrees Celsius. And that should be equal to the negative of this Q. So now we've got the 200 grams of the gold, which I should have put the substance with that as well. So this should be 200 grams of gold. I believe, yeah, we're going to have, what's that? AU, I believe, yeah. And so we've got the gold there. And that's going to be multiplied by its C value and its change in temperature. So we've got the T final here minus its original temperature of the 100 degrees Celsius. So if you are kind of keeping track of signs here, this is going to end up being a negative number, but then when you multiply it out front with that negative sign, this whole thing ends up being a positive value, which should match this being positive and this whole thing being positive in value. So that's kind of like how this works. If you don't have that minus sign, when you do the math later, you'll get something that's incorrect. You'll actually get a T final that just shouldn't be reasonable if you were to like think about the problem. So I worked through this problem with a student, and what they did at this point was they divided both sides by 50. That's totally fine. What you really need to do is just simplify. And you can't multiply this stuff by what's outside until you've simplified. So you can kind of cancel those out, or you can do the distributive property. So I'm going to go ahead and simplify these down to like one term on each side. And then distribute and solve for it that way. Okay. But that being said, there's a ton of different ways to go through the math here. Just plug it back in and see if it's reasonable at the end. That's the most important part when going through this problem. So I've got 50 times that 4.184. Yeah, it's going to be 209 point, what's that? 2. And these grams have canceled out there. I've got joules per degree Celsius, and that's going to be by the T final. I'm going to just do our color coding here. So we've got that times that gives you here. You've got T final minus 25.0 degrees Celsius. And then on the other side, we've got our, what's that, 200 grams times the 0.129. Yeah, this is 25.8 joules per degree Celsius. Those two numbers combined. And we need to have minus out front. And our T final right here. So then you can do distributive property. Now you can do this one step at a time. I'm going to do that for the purposes of the video, but I think a lot of students would do both the distributions at the same time. Just be careful if you're going to do that. So we've got the 209.2 times the temperature, the T final, minus some number. So we've got that. What's that? 209.2 times 25 degrees. So 5230. And now that I believe is just joules because the joules would have canceled out there. Yeah. So that's looking okay. And then we've got, you can either distribute the 25 and keep the minus out front or distribute that all at once. Either is fine. Just be careful. So I'm going to distribute. So we can say that this would be a negative 25.8 joules per degree Celsius times TF. And then minus times the minus, you get then plus whatever this number is. 25.8 times 100. Probably do that in your head. And at this point, when I was working with a student, they said, this seems more wrong than I thought. It's just tricky, the math. Like, this is just an algebra expression that we're solving for T final. So that's why it's super useful to be able to double check everything at the end. Okay. So we've got these two things equal to each other. We should be able to isolate for TF at this point. So you can add to both sides the 25.8 TF and kind of go through this. I am going to go through this a little bit slower than most students would do it, but it helps you keep track of it if you're actually just having stuff you can double check, right? So we've got that 209.2. It looks like we're adding that 25.8 to it. 235 joules Celsius times TF. And then we still got this on this side. And that on that side over there. So bring that over. Zero. Got 7810 joules. And that is now, yeah, because we added just to keep the things clear. Ends up giving us this number here. And that is now equal to what we've got here. We should be able to solve for a T final. It's looking like it's in the right range to me. Let's see. So we're going to divide that by the 235. Yeah. And so we're getting a T final right on the money, 33.234, etc. If we're looking back on sig figs, I think this is going to be limited to 3 sig figs most likely. These numbers were, yeah, limited to, it's 50.0, so that really should be 3 sig figs. Yeah, I'm seeing that ultimately this ends up multiplying out by things that are going to be 3 sig figs. So I'm seeing this as 33.2 degrees Celsius for our final temperature, which does seem reasonable with our estimate. We had said that this is going to go up a little bit, and that's going to go down quite a bit for the Q's to be equal. So that's the use of having the estimation done on this, is being able to see if your answer is reasonable or not. But you need to consider both M and C, so you really should multiply those together before you do that little guesstimation. So when you get to the end of the problem, most students are going to be like, I'm done with this. That took a lot of effort. So they're either going to get it right or not, just based off their first attempt. I would really encourage you to plug this back in. It lets you double check this pretty easily. And so it's worth doing. So if you think about, we've got these two different Q equations. We had the numbers for some of this stuff, but not all of it. But we can just plug them in and see if we do actually get the same value for our two different calculations. So we've got that 50 and that 4.1 for these values. And then it looks for our T final. We're getting a final of 33.2 degrees Celsius minus the 25.0 degrees Celsius. And we can do that multiplication. So we can see what this Q value actually is. So do our 33.2 minus 25.0. That's 8.2. And then we can just multiply that by these other two numbers. So that 8.2 times the 4.184. And you could, if you've already multiplied the 50 by that, you could use that, but I'm just using the numbers as they were given just to make sure, just to be going straight to the source. So this looks like this was going up 1,715.44 joules when we did that. And we can do the same sort of trick here with these numbers. We've got 200 in the 0.129 for our M and our C value here. And then for our T final, we've got that 33.2 degrees Celsius minus the 100 degrees Celsius. When we do that, we get minus 66.8 degrees Celsius. And then we multiply that by these other two numbers, and that should give you the Q here. Gold, and then this was our Q of the water. Yeah, so let's see what we get. Now that's negative 66.8 times the 0.129 times 200. It's pretty close. Remember, we had said this was really only accurate to 3 sig figs. So if you were to round these, it'd be that 1,720, but it's really like these are your sig figs. So these are equal and opposite if you were accounting for that level of accuracy that we really have within the problem. It should be fine. And you can also see that actually using your units in here kind of helps you keep track of stuff. So you can keep track of how these things cancel in the actual math. I'm being a little bit lazy and not writing out everything, but you can kind of see how the Celsius cancels out, leaving you with just joules, which would be my other big tip. Teachers love to do problems where they ask for answers in like kilojoules, so you're gonna have to do oftentimes one more conversion at the end of these. You're probably feeling at this point like, okay, I kind of get that, but that was a lot. If I was a chemistry teacher, this would not be on my tests. This would be on the homework, showing students that you can do this, but I would do the other calculations that don't have you looking for T final. So if you have like a Q given, you don't have to do this like fancy math. It's just plug it into the formula and solve for it. if you are solving for like a C value or something like that, if they've given you the T final, you basically have, like, let's say you have that information, that information, that information that will give you this, which means you kind of have this as well. And if you have that and that, then you could solve for like the C. So most of the math in these things is not requiring you to do like distributive property or anything like that. It really is just this one type of problem, which I see oftentimes taught, but not assessed. It is sometimes like the bonus question or like the one at the end to separate the A's from the B's. But like this takes some time to do, and your teacher has a lot to assess. They would rather assess more than just like this one thing. Um, but if they are, I hope you're able to double check by plugging it back in and getting an estimate before you do the calculation. Thank you for McLearning with me. Before you go, please check out the following services that I offer with my business. So if you click the link in my videos, this goes to my website. I might be changing it from Podia because I'm no longer doing the interactive videos for sale. I might put those up for free. But most of my other services are linked here. So you can see that I've got like a Teachers Pay Teachers and a Wyzant. The Teachers Pay Teachers has a lot of my assessments that I have for like the NGSS, as well as lessons that I made when I was actually a teacher in the classroom. So I've got quite a few things like CERs and other things on there. If you want to get one-on-one live support from me, either like with science or like working on like teaching support lessons and that kind of stuff, you can sign up through Wyzant. I have a link to there where you can contact me there, and we can schedule hourly appointments. And I've got a few other things on here like a Facebook page and other social media. And if you're interested in getting professional development with me for like a team of teachers, a whole page with information on that. So yeah, feel free to check that out. Thank you.